Hi guys, welcome to the another session of design and analysis of algorithms. In this session, we are going to discuss about another module 6, which explains about divide and conquer design strategy. In this session, we are going to discuss about binary tree traversals and their related properties, Strassen's matrix multiplication, and advantages and disadvantages of divide and conquer. In this session, we are going to see binary traversals, tree traversals, and their related properties. For knowing about the tree traversal techniques, first we need to see what is a tree and what is a binary tree. The tree can be defined as a non-linear data structure that stores data in the form of nodes. All nodes are connected to each other with the help of edges. Among all nodes, there is one main node, which is to be called as root node, and all other nodes are the children of these nodes. Coming to the tree, so here you can see this gives an example for tree. Here, these are all to be called as nodes. The main node is to be called as root node. Here, all other are to be called as children. Here, this node, this node, this node, these are all to be called as leaf nodes. These are all to be called as intermediate nodes. This is to be called as root node. Coming to the binary tree. Binary trees are hierarchical data structures composed of nodes, where each node has at most two childs, typically referred to as left child and right child. So, a binary tree is having at most two childs. So, here you can see the example of binary tree. 2 is the root node. 7 and 5 are the two childs of 2. And 7, which is having two childs, again 2, 6. 6, which is having again two childs, 5, 11. 5, which is having only one child, that is 9. 9, which is having only one child, 4. And all these 2, 5, 11, and 4, these nodes have 0 childs. That is, a binary tree is having a maximum of 2 childs. That is, it may have 0 childs, 1 child, and 2 childs, not more than that. So, I hope that you all understood what is a tree and what is a binary tree. Coming to the properties of binary trees. The maximum number of nodes at level L of a binary tree is 2 power L. Here, level is the number of nodes on the path from the root to the node, including the root node and the node what you are considered. The level of the root node is 0. The maximum number of nodes in a binary tree of height h is 2 power h minus 1. Here, the height of a tree is the maximum number of nodes on the root to the leaf path. The height of a tree with a single node is considered as 1. In a binary tree with n nodes, the minimum possible height or the minimum number of levels is log n plus 1. A binary tree with L levels has at least log L plus 1 levels. In a binary tree where every node has 0 or 1 or 2 children, the number of leaf nodes is always 1 more than nodes with 2 children. In a non-empty binary tree, if n is total number of nodes and E is the total number of edges, then always E is equal to n minus 1. In a complete binary tree, every level of the tree is completely filled except for the last level, which can be partially filled. That is, in a complete binary tree, all levels of the tree except the last level are completely filled. In a balanced binary tree, the height of the left and right subtrees of every node differ by at most 1. Right. All these are to be called as binary tree properties. Coming to the tree traversal techniques, What is meant by traversing a binary tree? Traversing a binary tree means visiting all its nodes in a specific order. So there are different ways of traversing a tree depending upon the order in which the tree's nodes are visited and the type of data structures that we are using for traversing the tree. So the major traversing techniques are in-order traversal, pre-order traversal, post-order traversal, boundary traversal, and diagonal traversal. We are going to see each and every traversal technique one by one. First, we are going to see in-order traversal. In-order traversal traverses the left subtree first, that is, which falls in order. Then it visits the root node, and finally it traverses the right subtree. That is, in an in-order traversal, the nodes of the binary tree are visited in sorted order if the tree is a binary search tree. So what is a binary search tree? Binary search tree means a binary tree in which always the left child is less than the parent and the right child is greater than the parent. So if it is a binary search tree, always the in-order traversal is present in the sorting order. Right. Now, in case of binary search trees, the in-order traversal gives nodes in non-decreasing order. To get the nodes of binary search tree in non-increasing order, a variation of in-order traversal, where in-order traversal is reversed, can be used. Now here you can see the example for that. Here, this is a binary tree. How the in-order traversal goes is, first its left child is visited. So for the root node, the left child is 2. And coming to 2, the left child is 4. So that's why first 4 is visited. Then 2 is visited. And coming to 2, again 8 becomes, for 2, the right child is 5. So right child cannot be visited first. If it is having left child, its left child is visited first. So 8 is visited, then 5 is visited, and then 1 is visited. And coming to this one, again I have left child 6 for 3, so that's why 6 is visited, then 3. Then coming to this, 9 is left child for 7, so 9 is visited, then 7, and finally the right child 10 is visited. The most right child is 10, which is visited at the end. Right, and we visit the root node at the middle. We visit the most left child in the first. Right. So this entirely represents the in-order traversal. Coming to the pre-order traversal. Pre-order traversal visits the root first, then it traverses the left subtree, and then it traverses the right subtree. The pre-order traversal is used to create a copy of the tree. That is, pre-order traversal is also used to get the prefix expressions of on an expression tree. In a pre-order traversal, the root node is visited before its children are visited. It is often used to create a copy of binary tree, and it is a common traversal for expression trees. Here you can see an example for pre-order traversal. So here this is a binary tree. So we first visit the root node. Then if you go for the left child, 2 is the root. That's why 2 is visited first. And then left child is visited. That is 4 is visited. Then coming to right child is visited. That is 5. Then left child 8. Then here coming to this time, right child, 3 is the parent. So that's why 3 is visited. Then it's left child. Then 7 is parent. So 7 is visited. Then it's left child. Then it's right child. That is always parent is visited first. That is root is visited first. Then left child and then right child is visited in case of pre-order traversal. And coming to post-order traversal. Post-order traversal, in case of post-order traversal, first it traverses the left subtree, then it traverses the right subtree, then the root node is visited. In a post-order traversal, the root node is visited after its children. It is commonly used for tasks like deleting nodes in a binary tree. Post-order traversal is used to evaluate postfix expressions in an expression tree. So here you can see an example for post-order traversal. So here this is a binary tree. First, always left subtree is visited. So that's why 4 is visited. And in this left, again the left is 8. So that's why 8 is visited. Then right is visited, that is 5 is visited. And then parent is visited, that is 2 is visited. Then coming to here left I have 6, I have 9, these 2 are visited. Then I have 10. Then I have, since this is a parent, this is visited, then this is a parent, this is visited, then this is a root node, this is visited. Right, like that first left subtree is visited, then right subtree is visited, and then finally root node is visited. And coming to the next one, boundary traversal. So here we represented before going to boundary traversal, we are seeing one same example for pre-order, in-order and post-order. So here you can see pre-order traversal, in-order traversal and post-order traversal. Pre-order traversal, always root is first visited, then left child and then right child. In case of in-order traversal, first left child is visited, then root is visited and then right child is visited. In post-order traversal, first left child, then right child, and then root is visited. So you can clearly understand. Here, pre-order, that is first root node is present. In in-order, root node is visited at the middle. And in post-order, root node is visited at the end. Like that, you can understand. So the difference of pre-order, in-order, and post-order. And coming to the boundary traversal. In case of boundary traversal of a tree, first left boundary, that is the nodes on left excluding leaf nodes, and then they are visited the leaves, that is consists of only the leaf nodes, and then it visits the right boundary, that is nodes on right excluding the leaf nodes. Like that it visits. So here you can see the example, how it is visited. So first left boundary means here we are seeing 4, 8. Here before going to first it visits all left boundary nodes and leaves, then it goes for right boundary nodes. So that's why first left boundary 4, 8, then 10, 14, 25. All these are the 4 is leaf, 10 is leaf, 14 is leaf, and 25 is leaf. And then it goes for right boundary. Right boundary is this one. Right. So here 22. Like that it visits. Right. So here coming to the diagonal traversal. So in case of diagonal traversal of a tree, all the nodes in a single diagonal will be printed 1 by 1. All the diagonal values which are present in a single diagonal. So here you can see the binary tree. How the diagonal traversal comes, all the diagonals are visited. So here first the diagonal elements 8, 10, 14 are visited. Then the diagonal elements 3, 6, 7, 13 are visited. Then the diagonal elements 1 and 4 are visited. So like that, the visiting of tree is done. So I hope that you all understood all tree traversal techniques. So those tree traversal techniques are in-order traversal, pre-order traversal, post-order traversal, boundary traversal, and diagonal traversal. Thank you for listening.